All right, hello everyone. So we are on to 3.5. We skipped 3.4. We're going straight into 3.5, which is slopes of lines. Now, most of you kind of have a familiarized idea of this based on Algebra 1, and we talked about how to find slopes of lines in order for graphs and if you are given points. So the slope is the rate of change between 2 points on a line and is the measure of the steepness of the line. So how narrow is it? Is it straight up and down? Is it slanted slightly? Or is it very wide? And to find the slope, you have to find the ratio and the change in y. So it's vertical change and the change in x, which is horizontal change. So this also can be said as rise over run. So that should be familiar from what you learned when you took Algebra 1. So rise over run. And so from here, example here, you'll go up, or you can always go up, and you can always go over. I still went up 3 and I still went over 2. The one thing you have to remember though is my line increasing or is my line decreasing? From here I am increasing from left to right, so I know my slope is a positive, and plus I have to rise first, or I can go over. Just know that y is always on top. Y is always on top, so that's why I have the slope of 3 over 2. Okay, and you might also know that the formula for slope is m, and it equals y1 minus y2 all over x1 minus x2. So that is if you were given any 2 points, you can plug in those points in order to find your slope as well. Okay, and so for example, like we have 2 and 3 for this point, and then we have 4 and 6. So if I were to plug those into this equation, I will still get 3 over 2. So those are 2 ways using rise over run if you have a graph, or if you are given 2 points, you can always plug it into your slope formula. Okay, so I have my next page down to the bottom. It says method 1 used the 2 black points, and method 2 is used 2 gray points. So it says here, most of the time these are slightly gray, and that's okay too. And then this one is they have black points on them, and that's all right. So, but we're just going to choose any two that have dots on them. Let's just do that. So we have, do you get the same slope using each method, and do you think this happens? So for this part, I have a slope. Let's say we want to use these 2 points. I have, if I rise up 1 and I go over 2, so it's 1, 2, so I have a slope of 1 over 2. Okay, and note I is positive because it is increasing. And let's see if I do the same for these 2. So I went up 2 and over 1, 2, 3, 4. So if I had the other slope, I'd rise, which is 2, and run, which is my x side, over 4. And I can reduce 2 over 4 to 1 over 2. So I got the same answer, so my slope is 1 over 2, or 1/2. And I'm going to do the same thing to b. So let's rise up 1, 2, and I go over 1, 2. Okay, so I have a slope. I have 2 over 2. However, is this increasing or decreasing? I am going downward, so it's actually negative. So whatever my slope is going to be negative. It's decreasing. So 2 over 2, negative 2 over 2 is negative 1. And let's see if I can do the same thing for here. I rose up 2, and I went over 2, and again, I end up with the same method. So my slope is negative 1. So no matter which points I choose on this graph, my slope will be the same. Okay, so now let's go over to the next page. I have draw. Pardon the bell, that just shows that it is after school time, so you know how late I'm actually here. So this part says work with a partner. You're drawing a line through point P using a slope of 3, 4. So here is P, and I have to have a slope of 3 over 4. So remember, 3 is like your y, it's rise over run. Okay, so I'm going to rise up 3, 1, 2, 3, and I'm going to go over 4, 1, 2, 3, 4. Okay, and then I can always go the other direction as well. I have 1, 2, 3, and I go over 1, 2, 3, 4. Okay, and so I have this line that's going through point P with a slope 3 over 4. And note it was a positive, so it has to be increasing. Okay, so it says use the same slope to draw a line through point Q. So I'm going to do the same thing and draw a line through point Q. So I have Q, I'm going to rise up 3, 1, 2, 3, and go over 1, 2, 3, 4, 1, 2, 3, 4. Okay, and I don't have room to go the other direction, and that's okay. Alrighty, so those have the same slope. Okay, and it says draw a line through point R using a slope of negative 4 over 3. So let's go through R, and it's decreasing. Know that, so it's going to go this general direction. So I'm going to go up 4, or actually down 4. I can go down 4. 1, 2, 3, 4, and go over 3. 1, 2, 3. Okay. So I have this line. And then my other point is actually going to be up here somewhere, but I do have my extra point there. So that is with a slope negative 4 of 3, and note that it is crossing R. Okay, not a perfect line, but that's okay. If possible, you can always use a ruler or your ID. That will help in order to make those lines straight. So C says, what do you notice about the lines through points P and Q? So the lines that are P and Q, what do I notice about P and Q? P and Q are actually parallel to each other. So P and Q are parallel to each other. Another way that we know that they're parallel to each other is because they have the same slope. So parallel. So if you want to put side note, I would say parallel. And remember, talk about that symbol. This means parallel. Have the same slope. Okay? All right, and what do we notice about P? Let's say we want to talk about P and R, or Q and R. So those lines are actually perpendicular to each other. So we say P and R. We also can say Q and R are perpendicular. Okay? Alright, so we said the points, but note we are talking about the lines here. So we can always say that and another point. So we're just talking about the lines that are passing through it. And so P and R and Q and R are perpendicular. Okay? So that means they created a box here. And how do I know they created the box? Based on their slope. So perpendicular lines and the symbol for perpendicular, we kind of talked about it in previous sections, looks like this. They have the reverse reciprocal slope. So that means if I have 3 over 4, what I would do to find the reverse reciprocal to make a line perpendicular to the line I'm given, I will flip my fraction. So then I have 4 over 3, and if it was positive, it now becomes negative. And this works both ways. So I can always, if this was negative, then I would make this positive, and so on and so forth. But we'll do more examples like that in a few. So from here, we have how can you use the slope of line to describe the line? And so you can use it, and we talked about this on the first page. You can use the slope of a line to describe the steepness of the line. Okay, so that's what slope does for you. And number 4 says make a conjecture. We kind of talked about this, so that's a unproven statement about two different non-vertical lines in the same plane that have the same slope. Okay, so let's talk about there are two non-vertical lines, so that means they're not up and down. They're not up and down. They can be slanted, they can be horizontal, and they're on the same plane, so they got to be on the same graph, and they have the same slope. We kind of talked about that with P and Q, or a line P and Q. So we have two different non-vertical lines in the same plane that have the same slope, they are parallel. Okay? So we know if they have the same slope, they're going to be parallel lines. Okay? It says make a conjecture about two lines in the same plane whose slopes have a product of -1. So we kind of talked about with here. Okay? So let's say we had that example, we had 3/4, right? So if we were to multiply it with, or have a product of -1, or we have to multiply it by -4/3, we have to multiply these two together. 3/3 is 1, 4/4 is -1, so the product of these two is actually -1. So what do we say about those who are perpendicular? If we were to multiply their products, they give me -1. So two different lines in the same plane whose slopes have a product of -1 are perpendicular. Okay? So no, product means to multiply. So multiply your slopes together, you should get -1. That's how you know that they are perpendicular lines. Okay? So moving on to the next side, I have some vocabulary. So we don't know sure what a directed line segment is. Don't worry too much about that. At least for my class, you will not. But the slope is the rate of change between any 2 points on a line. Okay? All right, and note you always have scratch work here, and so know if you come to class and we might do extra things on there, you can always get those from friends. But right now I'm just giving you the requirement in order to get through. So here we go with core concepts. We have slopes of lines in a coordinate plane. We have negative slope. Think of negative slope. That means negative slope. Think of the line is decreasing. And is decreasing from left to right. And that means it looks like this. So line J is decreasing from left to right, so it's going downward. So I have a positive slope. Positive slope is like increasing. So positive slope line is increasing from left to right. So that is like line K. So line K is increasing, it's going all the way up. Think about you getting more money instead of losing more money. So, and then I have a zero slope. Zero slope is dead set horizontal. It's constant. It's just a constant slope. So think horizontal lines, always constant slope. And have undefined slope, that is like line in, and it's going up and down. Undefined slope. Okay? So those are your different lines where you have negative, positive, zero, or undefined slopes. Okay? So if you're going to go over to the next page, there are a couple of theorems that we talk about. However, we're just going to know the theorems and know what they mean. So I have in a coordinate plane, two distinct non-vertical lines are parallel if and only if. We know that means biconditional. If I have if and only if, those are biconditional. They have the same slope. So the key word here is parallel lines and same slope. Okay? Alrighty. So if I had y...
There are after-school snacks in this.
Pardon the announcement. Again, I'm here after school, so they like to make announcements even when we're not in school. So, for example, if I had y equals 2x plus 2, and I had x plus 3, it has to have the same slope. So 2 would be the same slope. I just have different, different y-intercepts. Note these are y-intercepts. So that means where do they fall on the y-axis, okay? If I had a line and it says y equals 3x plus 3, and another line that says y equals 3x plus 3, these are not parallel, so not parallel because they are the same line. Okay? So they're the same line. So if I have the same line repeated, they're not parallel because there's only one line. But remember, these are y-intercepts, and you just have to have the same slope. Okay? So same slope, different y-intercept. Okay? Then let's talk about slopes of perpendicular lines. So know the perpendicular lines is their product. The product, so product, perpendicular, have a slope of -1. So if I had an example of y, same example of y equals 2x plus 2, I need to find the perpendicular slope of it and say it's like +1. Let's say I didn't know how to find the perpendicular line to this one. I could take 2 over 1, because that's the same as 2, right? And then what I'll do is I'll flip it. So flip your fraction. I have 1 over 2, and this is positive, so my new one is negative. So my reciprocal line or slope is -1/2. Okay? Because if I were to multiply 2 over 1 times -1 over 2, I get -2 over 2, which gives me -1. So my product is -1. So if I wanted to change it, remember I can turn my whole number into a fraction by putting it over 1, and then I will flip it and put a negative. If this was a negative, I would do a positive. So if I were to do the other way around, let's say I had y equals 3x plus 3, or a -3x plus 3, then my new one would be, let's find out. So if I have -3, that's the same as saying -3 over 1, okay? And what I do, I would flip it. So think flip first. So I have 1 over -3, and because it's a negative, this now becomes a positive. So that negative goes away. So it's a positive 1 over 3. Okay? So 1/3. Okay? Alrighty. So on the next page, I have a couple of extra practice problems. So the first one says, find the slope of the line that passes through the given points. So I'm only going to do a few for each one. Okay, so I have 4, 1, -2, -2. No, I don't have a graph, and so I can't naturally do rise over 1, but I can use the slope formula. And the slope formula is m, and then I have rise, so that's my y value, over run, which is my x value. And so I just plug in what I have. So 4 is x1, 1 is y1. Then I have negative 2 is my x2, and this other negative 2 is my y2. So plugging it in, I have y1 is first, so I have 1 minus my negative 2. Remember, don't try to keep them together. Keep the negative 2 where it's at. You still have to subtract. And then I have x1, 4 minus my negative 2. Remember your sign changes. So this becomes positive, positive. So 2 plus 1 is 3. And this becomes positive, positive. And so 4 plus 2 is 6. And if I wanted to reduce, 3 over 6 is 1/2. Okay? And you'll do the same for number 2. Let's go down to number 3. Number 3 says find the coordinates of point P along the directed line segment AB. So AP to PB is the given ratio. Alrighty, so for 3 and 4, it says find the coordinates of point P along the directed line segment AB. So AB and PB is the given ratio. We're actually going to skip these two because these we're going to get more in depth on the next lesson. But if you want to go on, we're going on to 5, and it says determine which lines are parallel and which lines are perpendicular. So the lines that are parallel here are, let's see, we have P. Let's look at line P here. I know it gets a little confusing. So we have line P. What's parallel to that would be line Q. So P is parallel to Q, okay? And we can do that because we can find the coordinates of each one, and we can notice that they're parallel to each other. Always try to do the math because they might look like they're parallel, but we won't know until we do it. So P will be parallel to Q, and then what would be parallel to another line? So S and R look like they might run into each other later on in life. So let's talk about T and R. So T and R look like they're parallel to each other as well. So R is parallel to T. Now, what ones are perpendicular? So these are parallel. Let's talk about ones that are perpendicular. So ones that are perpendicular across each other, that means they kind of create that box. So it looks like T might be parallel to Q, but we cannot be certain until we do the math. But S is parallel to P. It looks like it makes that nice box here. It might look that way, but again, we can always do the math. And so I would like you to see it for yourself. See if you can find 2 points and plot the line for me. So we have S is perpendicular to P, but S can also be perpendicular to Q, especially since P and Q are parallel to each other. So S is perpendicular to Q. So these are perpendicular. Okay, so show me the math. Give me 2 points to prove that what I just stated is true. All right, and we go down to number 6. It says tell whether the lines to the given points are parallel, perpendicular, or neither, and justify. So let's start off with, I have 2 lines here. Let's see if I can just find the slopes of both of these lines. So if I did line 1, let's find the slope. So I have x1, x2, 0 is y1, 2 is y2, and remember we're using our point or our slope formula. So we have y1 minus y2 and x1 minus x2. As long as you have your x's on the bottom and your y's on top, it really doesn't matter what order as long as your math is sound. So let's start off with y1, so I have 0 minus 2 on top, and then I have 2 minus a negative 2, okay, on the bottom. So remember our line changes, I have negative 2 on top, the signs change, so I have positive 4, and if I were to reduce that, it turns to a negative 1/2, okay, and we'll do the same thing to line 2. So I have negative 2 minus 4 on top, and I have 1 minus 4 if I were to label these correctly. Okay, and so remember our sign changes. So I have a negative 6 all over a negative 3, and the has changed to a positive, and I can reduce this to 6 over 3, and 6 over 3 is 2. So obviously they can't be parallel, because parallel means they have the same slope. These obviously do not, but let's check to see if they're perpendicular. Let's multiply them together. So I have negative 1 over 2 times 2 over 1, and that does give me a negative 2 over 2, which gives me a negative 1. So if my product is negative 1, is parallel, perpendicular, or neither? It's definitely perpendicular. So justifying my answer is the math, and my answer is perpendicular because I multiplied both of their slopes and it gave me a negative 1. And I knew that it was not parallel because parallel means they have the same slope. Okay? Alrighty. So that concludes 3.5 notes. And again, there's some stuff that you'll fill in on your own, like you'll try number 2, and then also give me the math on number 5. And if you have any questions, you know where to find me. I have tutorials Wednesdays and Thursdays after school till 4 o'clock. And if you need me by appointment, please email me at mariahmartin@misdmail.org. Thank you so much, and I will see you in class.